Okay, in today's class period here, we are covering section 9 of systems of inequalities. No context, meaning we don't have a word problem that goes along with what we're doing. Okay, well, what is a system? A system is two or more linear inequalities, and let me show you what it actually looks like on your paper. Sorry about that. So, system of inequalities is two or more linear inequalities. We're going to graph them together, okay? And so the solution is going to be where the set of points that satisfies those inequalities, and that's shown by where the shading overlaps. So we're going to show the solution by where the shading overlaps. Okay, so looking at the first example, we're going to have to determine how to graph the equations or inequalities first. So you ask yourself, am I in slope-intercept form or am I in standard form? Both of these two equations are in slope-intercept form. So let's graph the first equation that says y is greater than 4x minus 3. So minus 3 is my y-intercept. So we're going to put a dot at negative 3. And then our slope is 4 over 1. So from the y-intercept, we're going to rise 4, run 1, rise 4, run 1. And then we have to either use a solid or a dashed line. This first inequality is just greater than, so it's going to be dashed. So draw in a dashed line with your ruler. And now instead of shading, we're going to draw arrows to the direction we would have shaded. So we've been testing 0, 0. So if I go here to my first inequality, I would have 0 is greater than 4 times 0 minus 3, or 0 is greater than negative 3. That is true. 0 is bigger than negative 3. So before, I would have shaded this whole entire side. Instead, I just want you to draw 3 arrows, showing that we're going to shade that whole side. But we have a second inequality, so I'm going to change colors here. Okay, and we want to now graph y is greater than or equal to negative 2x plus 3. This time my y-intercept is at positive 3. Okay, and my slope is negative 2 over 1. So I either need to go up and to the left or down and to the right. And this time my graph would be a solid line because I am equal to. And we need to decide which side we would shade from the second inequality. So to test that, I would have 0 is greater than or equal to 2 times 0 plus 3, or is 0 bigger than 3? That is false. Okay, so here is 0, 0 off of my second line. So I need to shade the other way, away from 0, 0 for the second line. I'm going to give you a couple seconds here to process that. You have two lines drawn. You have arrows pointing off of both lines, and you want to look at where do they go in common. Where do the arrows point together? This top triangular area there is where the arrows point together. Okay? So let's look at another example here to keep practicing. Here's example number 2. Again, both of these are in slope-intercept form where the y is by itself. So my first inequality here, I'm starting at positive 3. And my slope is negative 5 over 1. If you go down, go to the right so that you get a negative slope. Make sure you do not go down into the left. Okay? Draw in a solid line because I am equal to. And now which direction would I shade? Again, I want to see if 0, 0 would be true or not. So is 0 smaller than 3? Because 5 times 0 is 0. Okay, so it is smaller than 3. So I want to shade towards 0, 0. Okay? Second inequality, I only have one variable. So if that's a y, I'm going to put a dot on the y-axis. Y-axis at negative 2. It needs to be a dashed line. And it would be horizontal, showing y is greater than negative 2. And now where would I shade? I want the y's, is 0 bigger than negative 2?
Yeah.
Yes, so I want my arrows to point up towards 0, 0. And so this large area over here is where my shading or my arrows is going to overlap. So this content is very similar to what we have been doing with the word problems. We have to test 0, 0s to figure out what's true or false. The main difference is we're not just in the first quadrant with positive amounts of money and positive days and whatnot, but I just have all 4 quadrants and I'm lacking that story problem. So let's go ahead and look at example number 3. This one says y is greater than 3 and y is greater than or equal to negative 1 plus 1. I would like you to go ahead and try this problem, please. Go ahead and try to graph both lines, both inequalities. Use your arrows and figure out where the shading would overlap. Give you about 2 minutes to try this one, and then we'll look at example 4 together. All right, let's go ahead and look at the solution here for number 3. So again, this top equation here has one variable by itself. Again, we'd be plotting a dot on the y-axis because it's referencing y. Again, a dashed line. Okay, and I would want to see if 0 is bigger than 3. 0 is not bigger than 3, so this is false for this first inequality. So I would shade away from 0, 0. Second inequality, I'm starting at positive 1, and my slope is negative 1 over 1. So this one I would go down into the right again. And I need a solid line this time. And is 0 bigger than 1? Testing that second inequality. 0 is not bigger than 1, so I need to again shade away from 0, 0. Let's see. And so where those shading overlaps is this kind of unique shape up here in this area here. Okay. All right, so this fourth one, I wanted to look at it together because a little bit different format than what we've had so far. These two equations are now in standard form. So to graph, we're going to use our intercepts. So intercepts for this first inequality, I would have 4x equals 9 or negative 3 equals 9 to find my intercepts, right? Plug in 0 for y, it disappears. Plug in 0 for x, it disappears. When I divide 4 by 9, what do I get? It's a decimal. 2.5, right? We'll just estimate where that's at. That's fine. And then my x-intercept, or excuse me, that should say y. My y-intercept would be negative 3. 9 divided by negative 3 is negative 3. So on the x-axis here, I would be starting at 2.5. The y-axis, I would be down at negative 3. And we would want a dashed line. Yes?
If we do 1/4, if we do 2.5, if we did that, it'd be 10. So 2.5, 1/4.
You want it to be 2 1/4 instead of 2.5?
Yeah,
I think it's just going to be the 1/2 and 1/2 is what we're missing. I guess not. 2 1/4. Oops, I'm still on my pen tool there, or my line tool. It's not going to change where you place your dot there too much. Dividing by 2 was going to be, I was doing the 8 and 4 was 1/2 of it or whatnot. Okay. Thank you for clarifying that. So we have 2.25 and negative 3 as our intercepts. As far as shading goes, I'd be testing, plugging in is 0 less than 9. It is less than 9, so I would want to shade towards 0, 0 with this first line. Second inequality here, graphing. My intercepts, I would have x equals 6 and 3y equals 6. There's a 1 out front, so my intercept is just 6, where my y-intercept dividing is going to be 2. So going over to 6 on the x-axis, 2, positive 2 on the y-axis. Dashed line again. I'm going to just dash this one in purple. Okay, and shading, I'm checking, is 0 bigger than 6? No. So I want to shade away from 0, 0 on the purple line. And so then they're overlapping in this area up here. Okay. So at this time, let's go ahead and practice these skills on our Systems of Inequalities worksheet.